MBA panel discussion. We are very excited and looking forward to today's discussion on the future of batteries. And before we begin, I'll ask everyone who's joining us today to just enter in the chat where you're calling from and let us know as well what your questions and kind of interest in batteries, where it stems from. So if you have any pressing questions or where you think the biggest challenges in batteries lie, feel free to enter that in the chat and let us know as well your location. And yes, with that, a big welcome and thank you already to everyone for joining us. We have 4 fantastic panelists with us today, and they'll be sharing, their diverse and very distinct perspectives on the future of batteries. So we look forward to this conversation. Welcome, everyone. And great, we'll now begin with a short presentation. Battery Associates and Battery MBA are running this panel, and so we'll just set the context for this discussion. And after that, we'll hear an opening statement from all our 4 panelists, and then we'll move on to a Q&A. So I will be introducing all our 4 speakers in more detail later on, but as you can see, we have with us today Claire Miller, who's the Director of Technology from Octopus Electric Vehicles. We have Malte Gallée, who's a member of the European Parliament with the Green Party. We have Céline Büchel, who's the Associate Director of S&P Global. And we have Auke Hoekstra, who's a researcher at Eindhoven University and also the founder and director of Neon Research. So very, very excited for today's discussion. And yes, welcome again. Now, Simon will briefly tell us about Battery Associates in just one slide, and then I'll tell you more about BatteryMBA.
Thank you so much, Amadine. Also, really big welcome to everyone here on the BatteryMBA program, but also everyone listening in from LinkedIn. I see from all around the world. So please keep coming. The location where you're based, it's a really amazing audience. Really grateful for all of you to share your time with us. The same for YouTube. We know there's also quite a few of you watching. So please, we want to make this interactive. Put your questions already in the chat. Tell us where you're calling in from. And we hope we have a really exciting discussion coming up. This is just one quick slide, just introduce ourselves. If you haven't heard of us yet, with Battery Associates and what's our vision, what's our mission. And our mission is to create a sustainable world through the power of people and battery innovation. That's what really brings us together. We want to create positive impact. And the different ways we do this is one is education. That's also part of this event today through the program. Also, I'm going to share a bit more about in a second. But also here in the Battery Pro, we're also advising organizations, and we're really trying to create positive discussions there, as well as our battery lab, where we do hardware and software, mostly open source. Unfortunately, with the background, I cannot show you right now, but behind me you would see some nice devices we're developing. So yeah, we are having a really wonderful community, and we have ambassadors in over 55 countries or so. So really grateful to be really embedded in this amazing community of amazing people around the world. So Amadine, over to you.
Absolutely. Thanks so much. So as mentioned, we have a couple of our initiatives that are around education, because batteries is obviously a topic that many people are interested in. But we have identified that there's a real need to help upskill the future task force and the professionals who will be helping make the battery sector more sustainable and also more inclusive. So to this end, we created the Battery MBA, which is a 12-week executive program that helps accelerate the careers of existing and aspiring battery professionals. As you can see from this slide, we have already 120 plus alumni from 30 countries. And that aspect, the network aspect of the program, is one that's very important to us, because our idea is also to help create a network of battery professionals who can help together make this sector, again, more sustainable and inclusive. So very happy to have many of our participants with us today. And in that same spirit, we do emphasize that we want to make this program as diverse as possible. So scholarships are also available for people from underrepresented profiles and background in the battery space who'd like to, accelerate and train their skills further in that space. That's it for the Battery MBA. If you look at the next slide, you'll see some of our participants and the companies that are represented through the cohorts. And the last 4 cohorts that we've had notably have affiliation with companies that really span the battery supply chain. And that's very much our interest here as well, to have many voices represented. And very much like today's panel, we hope to bring in different perspective, whether that be policy, academia, the business, obviously, and market research side, as well as upstream, midstream, and downstream elements of the battery sector. So very pleased to have all these individuals and their companies join us, including most recently Esval, Tesla, SAP, and then a couple of labs as well around the world, and many more to come in the next cohort. Great. And with that, just a word from our participants. Again, very important for us to emphasize that we are keen to have more women join our program. So we currently have 35% women participants among our participants and alumni. And as you can see from some of these testimonials, that's very much one of the aspects that was most appreciated about the program. Other aspects from those testimonials include the access to the continuous training. So we offer access to past lectures and future lectures as well, to make this training as dynamic and up to date as possible with all the changes that we're seeing in the space. Last but not least, the next cohort is starting on May 9. This panel is closing the existing cohort, and we look forward to seeing many of you join us on May 9. And we have a special discount for anyone who'd like to join us today, because we assume that if you're tuning in now, you're interested in the battery space. So let us know, contact us, and also just feel free to submit an enroll form for a €100 discount if you sign up today. And that's it on the Battery MBA front. And with that, we very much look forward to today's discussion. Great. So let me introduce our panelists. And as I mentioned before, they would then offer their introductory thoughts. We are tackling the broad topic of the future of batteries today. And without further ado, let me introduce Céline Büchel, who's the Associate Director of S&P Global. Ms. Büchel is an expert in market research for battery raw materials, including notably cobalt and nickel. Her analysis includes profound knowledge of battery technology, environmental and social aspects of mining, as well as other topics such as recycling. Ms. Büchel was the lead author of the first strategic report called Cobalt, Cobalt Minerals and Cobalt Chemicals. She also contributed to strategy consulting project on net zero carbon future and energy transition as subject matter expert of the battery supply chain. And as a speaker and panelist for battery raw materials, she regularly attends conferences and chaired sessions such as the Battery Tech of the Future, What's Next, at Sarah Week in Houston, Texas, where she's actually currently now. Ms. Büchel holds a first-class Bachelor and Master's of Science degree in Chemistry and Business Studies from the University of Zurich in Switzerland. And with that, welcome, Céline, and we look forward to your presentation.
Thank you very much for the kind introduction and the opportunity to be a panelist today. Well, last year, the seemingly never-ending downward trajectory of lithium-ion battery prices stopped. And the reason for this trend reversal are skyrocketing prices of battery raw materials. And this is clearly giving momentum for alternative technologies. But before I'm going to share the S&P Global view for the next 10 years, I'm very curious about the panelists and the audience perspective. So first, I would like to ask, who drives an electric car? So please feel free to put your answer in the Zoom poll, or when you are on LinkedIn or YouTube in the chat. So let's see who drives an electric car. So far, we have someone, right? Okay, so we can move on to the second one. So we do see there are a few people who have an electric car. And the second question is, do we agree that probably all these electric vehicles from our audience have a lithium-ion battery installed? I already see not all agree on that. I'm curious about their reasons. We can discuss that in the Q&A, but let's continue with the third question. And here it's about the prediction, how many alternative technologies we will have in 10 years. And most of the people say it will be over 10%. Okay, so let's compare that with the S&P Global prediction. Good. I think so. Here you can see the outlook. I hope you can all see that. Otherwise, please interrupt me. It's the outlook for the battery demand for 2030. Let's now just assume in 10 years, the battery demand for electric cars will be 3 teragigawatt hours. That means if we have 10% alternative technologies, we need 300 gigawatt hours. Well, I don't know if somebody wrote in the comments if solid-state batteries are included in the alternative batteries or not, because this makes a huge difference. Actually, solid-state batteries are just a derivative of lithium-ion batteries, but also in our forecast, we say this is an alternative technology. And with that, also S&P Global says 10% will be feasible in 10 years. But it doesn't matter like what the percentage exactly is. What is really important to understand out of this picture is that the dominant role will be still a lithium-ion battery. And with that, I would like to share the cathode breakdown. Cathode, because they are the most expensive part. I can still see the outlook of the batteries. So here we go. Here we have actually 3 different main trends. Let's say we start with the conventional lithium-ion battery, where we have a graphite anode mixed with LFP cathode and the cobalt-rich cathode. Then in the middle of the chart, we have the anode combined with silicon and graphite, and together with high nickel-rich cathodes. And at the end, we see it's getting more and more diverse. So we also see NMC271, so manganese-rich cathodes such as LNMO, NMCA, etc. Okay, so this is driven by energy density, cost, and at the end, it's more a mixture of cost, energy density, safety, and ESG. So, still not the next slide. So yeah, we are doing different scenarios. Basically, we do a maximum scenario, because if you talk about battery raw material demand, you want to have the maximum, and it's really interesting to talk about supply and demand. This is why we lowered the LFP share, that we have the maximum amount for nickel, cobalt, lithium, manganese. But I'm not going into the details here. If you are interested in more, we can discuss this in the Q&A, as well as a battery supply chain with the different regions which are involved. But coming back to the 10% alternative technologies, what could that be when we are in the electric cars? In our forecast, we say probably solid-state batteries and sodium-ion batteries for electric vehicles. Why? Well, solid-state definitely has the advantage of high energy density, and with that, lower cost and safety. However, they still use an NMC cathode, which doesn't solve the ESG problem. With sodium ion, we really have an alternative to lithium-ion batteries, but the energy density is smaller. There are also other alternative technologies which might be more interested for stationary energy storage system. So thank you.
Amazing. Thank you so much. And we look forward to hearing from the participants and those who are joining us from LinkedIn. If you have any questions, please let us know. Otherwise, we'll move on to our second intro statement from Auke. And thank you so much, Céline, for sharing those thoughts on the future of lithium-ion batteries and looking at the impact of some of these battery raw material. Looking forward to the discussion. So we would like now to hear from Auke. There were some connection issues in a moment ago, but hopefully Auke is with us now. Auke, let us know if you can hear us and if your connection is okay.
Can you hear me?
Yes, perfectly. That's wonderful. Great to have you with us. That's the most
important thing.
Yes, absolutely. So let me introduce you and then the floor will be yours. So Auke Hoekstra is an academic researcher at the Eindhoven University of Technology. He's also the founder and director of Neon Research and Zenmo.com. Both model how we can quickly transition away from fossil fuels using a bottom-up agent-based methodology that respects individual freedom, heterogeneity, and technological learning. Aside from that, he's also been predicting the dominance of solar since 2007 and wrote his first book about electric vehicles in 2009. For all these reasons, he's been following developments in batteries closely for about 15 years, and he's always astounded at the speed at which batteries have started and are continuing to develop in recent years. So really a thought leader in this space, and looking forward to your insights, Auke. The floor is yours.
Thank you very much. As you know, I was invited to join shortly before, so I didn't prepare a presentation, but what I think is most important to understand is right now the amount of electric vehicles that is predicted to be produced is dwarfed by the amount of battery factories that are being planned. So it's really interesting to see that the amount of battery factories being planned in Europe is enormous. And the only question we have basically is where do we get the raw materials? So in the whole development that we're seeing, raw materials are the big challenge. Fortunately there, and my previous panelists just gave a couple of good examples, there's a lot of opportunity for substitution. For example, lithium could be substituted by sodium if that ever became a problem, which is unlikely, but still. More than half of lithium now comes from Australia, has sort of geared up its lithium production in a very short time to take over of South America as the dominant leader in the field. But also, if you talk about cobalt, for example, it's not really a problem in terms of material scarcity, but that gets talked about a lot because of basically working conditions that are unacceptable in Congo. But something I think we should solve not using cobalt, but by improving working conditions. And basically what we're seeing is that a lot of people like to say there's a sort of automatic reaction always to say, oh, now we're sort of dependent on oil and gas, especially from Russia, for example. Now we're getting dependent on raw materials, and that's simply not true. It's a very, very different proposition. You need you pay about 50 times less for it. It's the world all over the world, and it's very substitutable. So yeah, I hope I can contribute more when we start discussing things. But I fully agree with the pictures that were shown so far by Céline. Only I think that the LFP might be a bigger share in the future if recent. If you have to believe many recent manufacturers, Tesla and others, but still. And I'm also a fan of lithium metal, but I'm not sure whether that will pan out. So these are my introductory remarks, Amandine.
Thank you so much, Auke. And yes, I'm interested in hearing what others have to say indeed on the role that LFP might play among other. Yes, and so thank you so much for this these talks, these introductory thoughts. And now we will hear from Claire Miller from Octopus Electric Vehicles. And very happy to have you with us, Claire. You are the Director of Technology and Innovation at Octopus Electric Vehicles, which is part of the Octopus Energy Group. And you've worked on EV adoption and use cases for smart connected grid, including vehicle-to-grid, V2G, and smart charging. You are passionate about solving real-world problems and delivering new technologies to market, and most importantly, putting into hands of users the tools and technologies they need to make a positive impact. Claire holds a master's in engineering from Imperial College London, and in 2021, she was a recipient of the Women Powering Smart Energy Award for Engineering, and in 2022 has been recognized as a top woman in EV in technology by the EV Summit. Welcome, Claire, and looking forward to your insights.
Thank you very much. And thank you to Battery Associates and BatteryMBA for having me. So my opening remarks are really about the customer, following on from that little bio. Thank you, Amandine, for reading that out. What I've been focusing on in terms of the battery and putting that into the hands of the customers, and in terms of mobility and that crossover between mobility and energy for over 3 years now, is vehicle to grid. And some of you may be aware that we've been running at Octopus a trial which is called Powerloop, which is a part UK government funded project, part of a group of projects they funded around vehicle to grid. And our project has focused very much on the customer. And so what I'd like everyone to have a think about, as well as the detail around the raw materials that go into batteries and that manufacturing supply chain, is when you put that into the context of the uptake of EVs, and we saw from Celine's graphs of the demand for batteries and the need for scaling up of manufacturing, how many of those vehicles will actually end up in the hands of a customer, and how we get across to those customers how they can make those batteries available to the grid. And so what Powerloop has done is to help give our customers, a small group, 135 so far, a real vision of the future, where their mobility asset, their car, is also an energy asset. And we've been able to demonstrate how it feels for those customers to use it as a vehicle and use it as an energy asset. And really, the three key things that we take away from using those vehicles as a vehicle to grid battery asset for the customer is it gives them access to cleaner energy. We're a fully renewable supply company at Octopus, to cheaper energy. And that's in terms of being able to pass on the benefit of flexibility, of using those batteries to help to balance the grid and to take part in flexibility and ancillary grid balancing markets, to pass that on in the form of cheaper tariffs. And finally, to give the customer choice. So to give them choice about how and when they use energy. And so really, I want everyone to be thinking about these batteries, not necessarily just as standalone chemistries or physical entities, but these are a real part of people's lives. They will be, in the next 5-10 years, a very important part of people's lives. And actually, it opens people's eyes when they have an electric vehicle, when they take part in these sorts of trials. It makes them think about how they use energy, when they use energy, and the different costs of timing their energy use. So my perspective on this panel today is about making it real for customers, cleaner energy, cheaper energy, and giving customers choice. Thank you.
Amazing. Thank you so much. And really glad that you're here to offer this very specific perspective. So looking forward to this conversation later on. And last but surely not least, Malte Gallée is here with us and representing and closing this loop of 4 panelists with the policy voice, and as a member of the European Parliament representing the Green Party. Mr. Gallée has been active in various NGO fundraising campaigns across 70+ cities and he's currently shadow reporter for the European Battery Regulation. He notably serves the European Parliament as a member of the Environment Committee, Consumer Protection and Internal Market Committee, and Development Committee. Prior to joining the European Parliament last December, Mr. Gallée worked on a number of information campaigns for aid organizations with Dialogue Direct. Very, very happy to have you with us. You must have been busy recently, Malte, and looking forward to your thoughts. Thanks for being here.
Yeah, thank you for the invitation. And indeed, it has been some quite exciting months for me. I just started, and yeah, you can imagine, like, especially the last weeks, they hit us pretty hard, like all of us, like all the areas of policy were like suddenly shaken, and also ours, I guess. But yeah, I mean, like battery regulation is in the pipe already for 2 years now, I think, or more than 1 year, definitely. And I mean, like for us in the parliament, or for us as Greens, especially, of course, it's the main question, like how do we use legislation to really, protect from climate change, to stop climate catastrophe. And I think this battery regulation plays a really crucial role in that. So yeah, I want to point out like 5 areas of the regulation. Well, first of all, so far the regulation isn't all gone through yet. We will still go to the trialogue negotiations. So far the Parliament got his position, the Council got its position, and the Commission got the position, and so they all are set, and now we still need to negotiate. I want to briefly speak about the due diligence, the carbon footprint, the repairability, and the product passport, and the recycling in general, because I think this is really, I'd say groundbreaking in terms of legislation, but also really changes the battery market, I would say. First of all, let's start by the mining. Also, what Auke said. Yes, of course, it doesn't help people in DRC if we get the cobalt only from Finland right now. So this is why we really managed to negotiate a really strong due diligence in the battery regulation. And it's important. It's a regulation, which means it will cover all the companies that get active on the European market. So in future, if we get it through, this means that all companies need to make sure that that human rights are respected, that we have a grievance mechanism, so that they can complain whenever their rights are not respected, which is a big problem currently, and that we also have a remediation mechanism. So companies have to pay those people whose rights were not respected, or I don't know, who didn't get enough work protection in their mines or whatever. So I think this is a really big win. For the carbon footprint, I think this is also really revolutionary, because we will, like, companies will have to declare how much CO2 was emitted during the production phase, because there are always those rumors that production of batteries harms the environment as much as a combustion engine car, blah, blah, blah. And so like this, we basically really push the industry for energy saving production. So yeah, they will have to calculate, to label, and then we kick out the polluters basically. Then a really important part, like batteries have to be repairable and replaceable, especially like before, with the battery legislation before, they had to be removable from products. But I mean, like when they are removable, you can still break the product. And so from now on, if it goes through, of course, batteries have to be replaceable by like in phones and laptops and everything by the end consumers, which is a really huge win. And yeah, we keep the product in it safe. And yeah, what I also really like is the product passport, because I think there's a huge chance in it of like digitalization in general of our products, because like this, in this product passport, of course, we have all the information, for example, the due diligence and everything, but also like how much CO2 was emitted, what kind of battery it is. And this is really crucial for recycling them. Because if we have like good information on the batteries, then the recycling is much more better, much more efficient, and we can use much more material afterwards. And so I think this is really a revolutionary piece of legislation that we're working on at the moment, that can really contribute a lot to our more clean and greener future. And I'm really looking forward to the discussion with all these professionals that you are.
Thank you, Malte. And I'll let Simon now open the discussion. Thank you so much.
Yes, I'm just going to quickly add everyone. But thank you all so much for this really great opening, these kind of different positions. And I think everyone who also listens in, they can tell that, we've got a really nice representation here. You've got a really interesting combination from people from more from the research phase, more from the technology phase, from industry side as well, from the policy. And that's really what we love to bring together. So I'm extremely excited and really grateful for all of you to make your time available for being part of this discussion. I think there's a few really interesting, trends we have seen, and those have been discussed already in the chat. So please keep it coming. I see in all kinds of chats right now, lots of questions coming. We'll try to consolidate this, and of course, we also have a bit more time afterwards for the lucky participants in this program to have a bit of a discussion for the second half. So I'm also will maybe focus a bit more now on some of the LinkedIn and YouTube questions. But what I find really fascinating right now is, just looking at the topic, right, we're discussing today, we like to keep it always the same, which is perspectives on the future of batteries. And I think all of you have really provided a different angle to it, which are all really important. And I think it's really important also to see them maybe also in synergy and how they influence each other. So we really kicked it off with Céline looking at like, what's the future of materials, of battery materials? We look at, all the challenges we have right now, but also we think about what could come next. Like here, two things, sodium was mentioned. Also, I think Auke or someone mentioned lithium metal, I believe. So, there's maybe from technology side. And of course, there's many new, Céline showed much more nuance of different kind of material composition, etc. So there's a lot of momentum happening just on the material side. Then we looked a bit on, what comes next from technology side. And here we spoke about solid state, and this kind of came up, which also is a very important one coming as well. And like also really like, a lot of kind of developments as well, like how you put them more efficiently together. And of course, also looking at technology, recycling was mentioned a lot. We didn't speak about it too much yet, in the conversation we had, but it came up a lot on LinkedIn, a lot of discussion about the topic of recycling. Maybe we can address this a bit more as well. Then we also look kind of the future of use of batteries and EV users. And here we talk about concepts such as, a vehicle to grid, what Claire mentioned. I think is really fascinating pilot you have been doing in the work. I know in the UK, I've been doing quite some interesting work there in the past already. And there's a lot of movement around the world looking into this. How can you maximize the use of a battery? And also, there's different approaches, right? The one is to say, look, also use in a stationary context, other companies trying to get this EV to move as much as possible. And for this, that's another really approach. And there's also was a discussion on LinkedIn. Maybe that's you can also share a bit more, Claire. What do you do about all these users who use the EV all the time? Maybe like a taxi driver or something. Does that even make sense? Or maybe if you have self-driving feature, is there still room for that? And also maybe one thing with Auke, one reason why I know yours is originally from Twitter, because you've been debunking all these claims of saying, that EVs are worse than ICEs, internal combustion engines, because, there's more emitting in the beginning. And you showed kind of, that's actually much better than many people claim on the media, etc. So I know you're doing some really great work there, which brings me also to the last point, what Malte mentioned, more about reduction, of carbon and really thinking about this and saying we have to really take this into account. We have to take into account where the material is coming from, but also how can we reduce the overall emissions from our vehicles. And again, there's different approaches. One is, which I think is really, the advancement now future of regulation, putting into place that you have to reduce the emissions from the production, not just of the use side, which I think is a very important step. So maybe this is just helpful for anybody also just tuned in and maybe missed some of it a bit earlier to just kind of see some of the different patterns we've been looking at. And now I'm kind of curious also to, we don't have too much time actually. We have about 5 minutes or so left of the public part, unfortunately. It always moves very fast. And I would maybe like to get a bit your thoughts now, also thinking about what could come next, maybe in the 5 to 10 years? Where do you see it going? And I know there's no things right now discussed, regulation. Malte, I know you mentioned, this is happening right now, but it will be in place one way or the other. Something will be decided in the next, probably year. But if you think 5 years ahead, will, a regulation like this be, advanced in Europe, or are we seeing maybe more implementations around the world? That's maybe something interesting. Maybe also for you, Céline, from the material side, and what kind of can you see more happening there? Some different trends. Do you expect maybe there's complete new chemistries we never haven't thought about yet? Or do you think it's more about advancing existing ones and kind of see the trends move further? Also for you, Auke, I'm really curious also to see from the use phase, if there's any advancements. I think how low of emission maybe can also an EV come? And the kind of is there like any theoretical limits, or should we maybe have smaller vehicles, larger vehicles, things like this? Should be more shared mobility? I'm interested. And same also for you, Claire. What would you see in your industry from a charging perspective? Do you think we're all going to use vehicle to grid? Will this be the standard? How could this be done? Or how do we deal even with all the charger infrastructure anyways? That's been a big discussion before. So maybe we can go in this order, or any order which works. Also, happy to go to Malte first, maybe do it the other way around.
Okay.
Sure, of course. Wait, let me just check the chat here. Okay, perfect. Well, there was this question, like, how will it be like in 5 years? And well, first of all, like this legislation, ideally, as far as I know, it should get in place like next, like January 23. But I mean, like for each part of the legislation, there are different timings. For example, like there are phase out times and so on. I don't have them by heart, but yeah, like for example, companies are still they do not have to produce the digital passport immediately, but only from in, I don't know, year 25 or something like this. Yeah, so in the chat there was the question how to enforce human rights aspects outside the EU. This is the part, like this legislation will well, every company that places batteries on the European market has to comply. So they have to make sure that they comply with these rules, that they have this due diligence reports, that they have a remediation mechanism in it, that they have a grievance mechanism in it. And this is basically how we go around like other governments, because it goes to the companies that are active in the EU. And this is, I think, a pretty good way to protect human rights even outside of the EU. And at the same time, this will really strengthen EU market, I think. Yes, I think this was like the main question. I think I answered it, yes.
Fantastic. Thanks so much, Malte. I know we're going to have a more in-depth discussion afterwards. Maybe we can go to you, Claire. And I think also one thing also which came on LinkedIn, how to deal with degradation as well. Because a lot of customers, of course, worried about that. So what would you answer to that as well?
Yeah, thank you. Yeah, I get this question all the time, and actually, it's a natural one. I think when you initially think about this, but actually, we anecdotally have seen excellent results so far from Powerloop. No impact on the battery degradation. In fact, if anything, potentially a conditioning effect. And there are a lot more scientific studies. I can see Auke is nodding. There are learned studies. We're a very practical project. We're on the ground live with real customers, but there are lots of studies running which are looking at this. And in fact, the technology is well established around vehicle to grid. And we work with Nissan Leaf and CHAdeMO bidirectional charger, which is a reasonably established technology. So the good news is that batteries, it's a very nice life for a battery to sit on a driveway somewhere, gently cycling, charging and discharging. It's slightly more stressful for a battery to be driven, ironically, to have to drive you around from, lights to lights and stop start all the time. So yeah, we see excellent results so far from the trial, and we don't have any concerns at all about battery degradation. And I think also to back that, announcements from VW in the last week and from others, we see many manufacturers of vehicles now hinting, if not coming out openly and announcing that they will be bringing vehicle to grid, or V to X is probably the best way of putting it, because we haven't explored all these use cases. So, vehicles that are capable of discharging as well as charging. And I think that there was a question there about, will it work for this use case? Will it work for that use case? We're just scratching the surface of what the use cases will be in a domestic and a commercial setting, and across a range of vehicle sizes and scales. So, it's also important to keep in mind that, vehicle to grid is one particular flavor, but actually smart charging or decide to bring sort of service to the grid it's connected to in terms of being a place to store energy, that in itself is incredibly valuable, and all EVs are capable of doing that right now. And so that's something at Octopus that we're exploring in a real product that's really available now, a real service to customers in terms of our Intelligent Octopus tariff and flexibility service. So I think it's very early days for all these different use cases, and we just need more. We need more OEMs to bring their cars faster, and we need kind of accelerated around some of the software protocols that some of the viewers might have heard of around ISO 15118 is a really interesting one, and around OCPP 2.0. So there's some really interesting stuff coming. So it's just very early days at the moment.
Fantastic. Thank you so much, Claire. And I'm very excited to talk about this further as well. Maybe Auke, is there something from your side shared about the future of reduction? I think you're muted right now.
I agree with. Can you hear me?
Now we can. Yeah. Thank you.
Yeah. The exciting thing about electric vehicles is, of course, that the CO2 emissions can, in due time, go to basically almost nothing. When we produce batteries using renewable technology, and then drive batteries using renewable technology, and also produce renewable technology using renewable technology, you can go very close to zero CO2 emissions. So that's nice in a way. But yeah, we should really, I love to say we should be wary that we save the sky, but in turn demolish the earth, right? I mean, there's a balance there. The CO2 in the air is not everything. We should also be very wary about where we get the stuff that we clean the air with, so to speak. So I'm really, really happy with the battery legislation that is proposed, because that finally puts a clear focus on that part as well, not just the stuff that goes into the air, but also the stuff that comes out of the ground in that battery. And I think it will be very clunky at first, probably, and a lot of misstarts, but I'm super, super happy that the EU seems to be working towards using its power as a block to say, if you want to deliver to us, you better play by some rules that everybody agrees are good rules, but a lot of people in a race to the bottom are not abiding by. But now for us, you have to abide by them. And I think we will put a world standard there. As to a vehicle to grid, yes, there's a lot of exciting studies there. And it even seems that because you keep the battery not fully topped off all the time, but a little bit lower, and also because it's so gentle, that it could even make the battery last longer. And any rate, batteries last 10 times longer than about 6 years ago, and it's still moving in the right direction. So it's such a pity to have such a large battery and not use it as something to stabilize the grid. We could stabilize the grid entirely, at least over a day or something, using vehicle to grid. I'm sure we will use it. But finally, you said shared vehicles. Yes, if we want to use less materials, then shared vehicles basically mean we use 10 times less materials, so on average. And if we choose a vehicle according to our trip, then basically means that most vehicles can be much smaller, because for commuting, etc., a large vehicle is nonsense. So our simulation basically say you need about 30 times less materials. And for me, self-driving is the way to get us there, because if every car is self-driving, it becomes sort of a taxi from itself without extra costs. And then shared vehicles will be the future, I think. So many great developments, but they all have one thing in common: they need batteries. So I think very good that we have webinars like this.
Thank you so much, Auke. And yes, maybe Céline, would you like to add something?
Yeah, first of all, Simon, what a summary. And about what I haven't talked about was about the stationary energy storage alternative technologies. And interestingly, when I was at university, I've learned that redox flow is the battery to go. But yeah, we have all seen with the development of electric vehicles, the lithium-ion battery costs were pushed down so much that it's now even like more cost efficient to use the lithium-ion battery instead of the redox flow battery. However, the trend in lithium-ion batteries, when we have the cathode breakdown, is towards LFP. And as Auke mentioned, he said like the electric vehicle LFP could be even higher, and I agree. We have like 3 scenarios, one with 2030, 10, 20 or 30%. And imagine you have like 30% in the EV market. That means you have less available for the stationary energy storage system. And this gives again like momentum for alternative technologies in the stationary energy storage system. And this could be, as we said, the redox flow, but also sodium sulfate or lead carbon, for example. And another thing I would like to add on the automotive side, that was really interesting because I could interview Yang Xiao Horn, professor from the MIT, and I thought she will introduce me to a very exotic new type of battery. But interestingly, they are still doing research within the lithium-ion battery because we are still at the beginning. So their new technology is about liquid electrolyte, which does not have this problem with to be flammable. I mean, that's the problem. I want to go from liquid to solid. And also with her new electrolyte, the energy density can also be increased. Yeah, there are more technologies, but yeah, we can maybe discuss them in the Q&A.
Yes, looking forward to that. Thank you, Céline. With that, we'll close the public portion of this webinar and this panel discussion. So just wanted to say a big thank you to everyone for joining us on LinkedIn. Thank you as well for all the questions. We're sorry we couldn't address all of them, but be sure to follow our LinkedIn page for future events. We're very keen on having many more of such events. Our next big event will be Battery Day on September 23rd. 2022, and we'll also have another panel like this in the summer, so be sure to follow our page. And thank you everyone for joining us on